All right. Today we're going to talk about a language that you don't speak, you tap. A language made of just sound and silence that has, no joke, saved lives, helped win wars, and basically connected the entire planet. So yeah, let's dive into Morse code.
You know this sound, right? Dit dit dit, da da da, dit dit dit. It's SOS, the most famous message in the world. But really, think about it. In our world of high-speed internet and instant video calls, what can a simple on-off pulse possibly teach us? Turns out, a whole lot.
So to really get why it's so powerful, you've got to go back, way back. Because this wasn't just, a new alphabet. It was a completely revolutionary way to beat distance itself.
And this is the guy. Meet Samuel F.B. Morse. Now, he was a really accomplished artist, but back in the 1830s, he had this one problem he was totally obsessed with. How do you send a message, like instantly, down a wire with just a simple little pulse of electricity? See, before you could even dream of sending a voice, you first had to invent a language that electricity itself could speak.
The code we use today didn't just appear out of thin air. Morse's first attempt back in 1937 was kind of clunky. It could only send numbers. Then his assistant, a guy named Alfred Vail, came along and expanded it to include letters. But the real game changer was in 1848 when Friedrich Guernicke streamlined the whole thing down to its beautiful, simple essence. Just two things, the dot and the dash. And by 1865, that's what became the International Morse Code.
So that's the origin story. But how does this language of beeps and boops actually work? Let's break down the building blocks.
When you boil it all down, the idea is almost laughably simple. Morse code is just a way to turn our alphabet into sequences of short sounds and long sounds. We call them dits and das. The real genius isn't the sounds themselves, but the system that holds it all together.
Okay, now this is the secret sauce. This is the part that most people completely miss. Morse code is just as much about the silence as it is about the sound. See, a dit is our basic unit of time. A da is 3 times longer. But look at the gaps. The pause between sounds in the same letter is 1 unit. The pause between whole letters is 3 units. And the pause between words, a full 7 units. It's this precise rhythm, this grammar of silence, that turns a bunch of noise into an actual language.
And check this out. This is what that rhythm actually looks like as a radio signal. You can literally see it. That short little burst of energy, that's your dit. The longer one, that's the da. But those flat parts in between, the spaces with no signal, that's the silence. They're just as meaningful as the beeps themselves. Pretty cool, right?
And get this, it wasn't random at all. It was brilliant design. Morse and his partner Vail actually went through newspapers and counted up all the letters to see which ones were used the most often. And the winner, by far, was E. So what did they do? They gave it the shortest, quickest, most efficient code possible, a single dit. The whole system was built to be fast, right from the very beginning.
Okay, enough with the theory. You want to give it a shot? Let's get our hands dirty and actually learn our first couple of letters right now.
Now listen up, because this is the single most important tip if you're just starting out. The biggest mistake people make is trying to memorize charts of dots and dashes. Don't do it. You have to learn this as a language of sound. Your brain shouldn't be seeing dots on a page. It needs to hear a rhythm, like da-da-dee-dee, and just know that it's the letter C. Okay, ready? Here's your first letter. It's the most common one we just talked about, E. And it sounds exactly like this. Dit. That's it. Listen again. Dit. That short, sharp little sound is the letter E. You got it?
Awesome. Now for your second letter, T. This one is a single, longer sound. Da. Hear it? Da. Now let's compare. Here's E, dit, and here's T, da. You hear that difference? You're not counting dots and dashes in your head. You're learning 2 different sounds, 2 different musical notes. That's the key.
And this quote right here reveals the secret to learning it the right way. It might seem a little weird, but you don't actually learn by listening to it slowly. The sound of each letter, the dits and das, are always played at full speed. What you do instead is add extra long silent gaps between the letters. This gives your brain time to catch up and process what you just heard, without accidentally learning the bad habit of sending or hearing the code too slowly.
Okay, so it's a fascinating system, no doubt.
But in a world with 5G and satellites beaming internet down from space, is this thing just a historical relic? I mean, why should anyone still care about a code that's almost 200 years old?
Well, the answer is actually really simple. It's all about reliability. Think about it. When everything else fails, when the power grid is down, when the cell networks are jammed, when all our modern tech just goes dark, the raw simplicity of an on-off signal can still cut through the noise. It is the ultimate communications backup plan.
And hey, it's not just for emergencies. There are so many cool reasons it's still a valuable skill. It uses hardly any power, which is perfect if you're hiking or way off the grid. It's a universal standard, understood all over the world. But you know what? Maybe the best reasons are even simpler. It's fun. It's a real challenge for your brain, and it connects you to this incredible history of explorers and inventors. You kind of become part of a pretty special club.
And that kind of leaves us with one last thing to think about. We live in a world that is just saturated with noise and complexity, right? So maybe the greatest lesson we can take from Morse code isn't about the sounds at all, but about the importance of the silence in between them, the power of a simple, clear signal. You know, the very first official telegraph message ever sent asked, "What hath God wrought?" Maybe the answer, even today, is the incredible power of keeping things simple.